John Doe claims to have ESP, so we test his claim with an experiment. A person in one room writes down a number 1 through 5, and then John Doe guesses the number. Out of 3 people, find the probability he will guess 2 correctly. Let's start with seeing if we can use binomial distribution. Let's start with the B, the binary. Do I have 2 things? Well, yes. I have the success of guessing correctly. And I have the failure of guessing incorrectly. I. Is this independent? Yes, this is independent because one guess does not rely on the previous guess. S. What is the same probability here? Well, if I have a number 1 through 5, he has a 1 in 5 chance of getting it correct. So let's use the formula to figure out what is the probability he guesses 2 correct. We're going to start with n, which is the number of trials. The number of trials is, out of 3 people, find the probability he guesses 2 correctly. And he writes down, so our trials is 3. K, successes. We want to know 2 successes, how many times is that possible? Probability is 1/5. 1/5 raised to the successes is raised to the 2nd power. The next piece is technically 1, or Q is 1 minus P, which means really the complement of this piece right here. So 4/5 of the time is a failure. And the failure is raised to the distance or the number between 3 and 2, which is 1. So now we just have to simplify this. This first piece is a combination. In your calculator, you'll type the number 3, combination, which is math, scroll over to probability, option number 3, 2 at a time. When I simplify that, I get 3. 0.5 squared is 0.04. 4/5 to the first is 0.8. When I multiply all that together, I have 0.098, so the probability of that happening is approximately 10%.